And welcome everybody to today's event. And we're going to be talking about something very topical today. Of course, topical still is COVID-19 and all the things that have changed our lives as a result of that. So today's event is about COVID in a very spectacular way. And we're going to be looking at COVID breathing aids with the help of our speaker, Tim Baker, who I'll introduce to you in a moment. And the title of the topic was the UCL Ventura project, COVID breathing aid, and from 0 to 10,000 devices in 4 weeks. So by way of introduction, it goes without saying that COVID-19 has touched all of our lives. And back at the start of the pandemic, it soon became clear that there would be an urgent need for breathing aids to help those falling severely ill. And also that there wouldn't be a large enough supply of those breathing aids to meet the world's requirements needed basically overnight. So today we're going to hear the story of how a corridor conversation led to a team of thousands working together on the UCL Ventura project. And within 100 hours, the first prototype breathing device was being tested on the ward at University College London Hospital, UCLH. Those designs have since been licensed free of charge to over 2,000 organisations in more than 100 countries worldwide. So our guest today is Professor Tim Baker Mbe, Professor of Mechanical Engineering Design at UCL. And by way of background, after graduating from UCL Mechanical Engineering with a PhD, Tim worked in motorsport for over 20 years. Starting in Formula One, he saw his career evolve from engine development to engine design. And his team created engines that won races and championships at the very highest level, notably class wins at the 24-hour Le Mans. In 2004, Tim began running a design consultancy that helped clients in disparate sectors turn concepts into reality, using his expertise to inspire companies to take their ideas from a clean sheet through to production. And more recently, returning to UCL to share his practical engineering knowledge, his experience of prototype design and manufacture has contributed to several medical research projects. However, it was Tim's close links with Formula One that led to the partnership with Mercedes-AMG HPP for the UCL Ventura project that we're going to hear about today. In October 2020, Tim was awarded an MBE for his services to healthcare in the UK and abroad during COVID-19. And he was awarded the IMechE's James Clayton Prize for 2021 for his work in response to the COVID-19 pandemic in March 2020 and for his exceptional contributions to engineering education. So let me bring on Tim to the stage and we will hear his presentation. Do ask your questions as we're going through, and after that, we'll come back and have a chat about the topic and anything else that comes up from the audience. So a very warm welcome to you, Tim, and I'll hand the floor over to you.
Thanks very much, Nigel. Thanks for the introduction. Hello to everyone. Let me just get my slides started and then we can take it from there. Just 2 seconds. So hopefully, Nigel, can you see the slides okay?
That's great. The floor is yours, Tim.
Good. Okay, so we're going to whistle through a tour of what happened a couple of years ago. It's almost 2 years ago now, isn't it? Or just over 2 years ago. Just to explain really how it all, I had never any intention of getting involved in what became quite an incredible project. I kind of all the way along, I probably describe myself as being a bit of an accidental engineer. I seem to find myself into all sorts of fun positions and projects over the years, and this one absolutely, sort of beats anything that I've ever been involved in. So I'm gonna go through it as a timeline. So as we were back in March 2020, and just take you through the narrative of what actually happened, because I think it's really interesting, just from a obviously my personal perspective, but from an engineering point of view as well. So, as you heard, my background was pre-UCL in motorsport. I kind of describe myself as being paid to do my hobby for quite a number of years. I never had any intention of coming back into academia whatsoever. Actually, in the workplace, I rarely had patience for people who didn't really know what they're doing. But strangely, I discovered that I have a lot of patience to share my experience and teach young and enthusiastic engineers. This all came about because I returned some library books that were 16 years overdue, and funny enough, another corridor conversation led to me sort of starting part-time, and then it grew and grew to where I am these days. The slide that you can see on the screen there is that's actually Jos Verstappen. This is my era in the mid-90s. Jos Verstappen was for driving for the Arrows team that I was working on the engines for, a company called Breinhardt. It's amazing how quickly generations move on, because you've got Max Verstappen, you've got Magnussen's on the grid, you've got a young Schumacher, and also Carlos Sainz Jr., who I work with his father in the Ford World Rally team. So crikey, it's amazing how quickly you start to feel old, really, isn't it? I should also mention as we get started, so Rebecca Shipley was the co-leader on this project, and I'd worked with her on a couple of medical research projects. My background certainly wasn't in medical engineering at all. You can tell that I was, a bit of a petrol head. It was all about design and manufacture of racing engines. But I've always been, fairly good at making things, and that overlapped into some of the medical research where I had techniques for manufacturing. So I helped make a flow model for looking at vascular networks that could go into an MRI scanner, all made out of plastic, and I introduced them to the technique for characterizing that we use for characterizing fuel sprays, droplet sizes, that was then used for looking at spraying stem cells onto the back of an eyeball as a technique. So this is where the whole thing starts. So I'd known Becky. Funnily enough, we've been trying to catch up for about 18 months as the pandemic started. Saying, oh, we must sort of have lunch, we must meet up, see what's happening next. And if you remember back, it's all starts on Sunday, the 15th of March, when Boris made his sort of call to arms for the ventilator challenge. So the TV was on in the background. I happened to see what was going on, and just in my mind, I was thinking, if I was in that position, I kind of felt it was quite arrogant that engineers were suddenly going to start creating ventilators out of thin air when they're such specialized bits of equipment. If I was put in that situation, I'd have felt quite uncomfortable, because they are going to be life-saving devices. And also, I kind of wondered if you got into the high the high precision manufacturing that we're very good at in this country, and also into the motorsport supply chain. I was looking at the telly, and that was whizzing through in my head, not realizing that within 48 hours I would be, getting involved. So Monday the 16th of March, went into work as normal. Obviously, the papers are starting to have headlines. Everyone's starting to realise that there's going to be a crisis. We're going to be struggling for beds, etc. Again, back to the ventilator challenge. So by Monday, it was making the national press, and PM urges industry to make NHS ventilators. I think also when you look back at what we did, I've done quite a few sessions with various people wanting to know why we were successful, and I think you'll see in a moment that what it came down to was, in simple terms, it was kind of like, how many cases are we expecting to have? How many ventilators have we got at the moment? One minus the other equals the number of ventilators that we need. So let's go and make ventilators. Whereas we were we took a slightly different route, and we actually went against the grain, as you'll see quite shortly. So where's the activity going to happen? This is our engineering centre. This is our student workshop in King's Cross. This hadn't even been open for 9 months by the time that the pandemic hit, but it became it's now the spiritual home of the UCL Ventura team. Around that time, I had a meeting down at the IMechE headquarters. This is me walking through Trafalgar Square. I took pictures of these sorts of things without realising what the significance was going to be in the future. Usually, I don't really get my camera out very much, but for some reason, around this time, I did sort of take pickies. I went to the IMechE, met up with the people I was going to be talking to, and it was quite funny because a couple of the members there were saying, I don't know what all the fuss is about, give it 2 weeks and everything's going to be get back to normal. That evening I called in at the supermarket. All the pasta had disappeared. Do you remember all the painkillers disappeared off the shelves? And it was all a bit strange, really. So by that evening I'd already bumped into a colleague during the day on the Tuesday who it looked like they'd 3D printed the sort of the skeleton for a PPE mask, and we got talking, and I got asked if I could join a group and maybe we could do something to try and help. They were all very busy trying to organise their chain of command and who was going to be in charge, and they're going to have sort of gold command and silver, and nobody wanted to be bronze, so could it be a platinum or something else? And it all felt a bit disjointed. So out of the blue, Becky called me late that night and said she got something that she'd been approached, and could we do anything? She knew that I could do manufacturing, so I said I would go along. So we arranged a meeting for the Tuesday. First thing in the morning, Liverpool Street. Normally you'd be struggling to get onto the platform. This just gives you an idea of what it was like. It was fairly deserted by that point. So me and Becky got talking, and her main point of contact at the hospital was Mervyn Singer, professor of intensive care medicine, one of the intensivists that we were going to end up working with, and he'd been talking to his colleagues in China and in Italy, and had been learning about how they were going to, or how they were tackling the number of cases that they were getting. So we met in what's known as the Houseman room. It's kind of like the sort of the staff common room at UCL. Late on the Tuesday evening, and I can still feel it now. It's the most terrifying meeting I've ever had in my life. The picture isn't actually of the meeting. I didn't manage to capture one of those, but so we were being told that there were going to be thousands of patients, and that the army was going to be guarding the hospitals, and it's almost going to be martial law and civil unrest, and we're going to need lots of devices. So I think the statistics were there was something like 100. UCLH is obviously one of the teaching hospitals, one of the main teaching hospitals, so they've got a lot of equipment, and it's something like they had 112 ventilators available, but they only had 6 of these CPAP devices. Now, Mervyn had been, as I say, talking to his colleagues, and it seemed to be that the stats that he was getting, that if you got people onto continuous positive airway pressure device, so that's really just delivering a blend of air and oxygen at just slightly above atmospheric, that was keeping anything up to 50% patients from escalating onto mechanical ventilation. So I'd never realised just how invasive mechanical ventilation is, and that the issue is that once you're onto ventilation, the really hard part is to get the patient back off. I've since learned that it can take anything up to 2 weeks to wean a patient off a ventilator. It does have serious repercussions. So we were being asked, could we do anything to make CPAP devices, and could we make thousands of these devices? So it was very daunting to be faced with that, and we sort of said, yeah, okay, we'll see what we can do. I found it very emotional straight after the meeting, and I went away thinking about what we could actually do to try and help. So just to explain, CPAP, it's a way of delivering, as I say, slightly pressurized oxygen, and it splints open the lungs, and it means that you're going to improve the oxygenation And these days, some of the devices are quite sophisticated, but we were talking about trying to find an older device. I described it in that meeting as we needed to go for sort of carburetors rather than fuel injection. So it didn't need to be having touch screens and fancy electronics. It needed to be a passive sort of gas dynamic device. So that's what we were looking for. And again, just to sort of explain it very simply, you have your blend of air and oxygen delivered towards the patient who's wearing a mask, and then there is a valve that just like, it's a simple pressure relief valve that it's only roughly 10 centimeters of water is the typical pressure that these devices are running at. So on that Tuesday evening, this is where my contacts in motorsport come together. So what happened next was the other intensivist that we were working with, called Dave Brearley, quite literally, he went and robbed the that's one of their display cabinets. They have a sort of a small sort of museum display of equipment, and he dug out a device that hadn't been used for about 15 years called a whisper flow. It's quite a neat device. It works on the Venturi principle, so it uses oxygen to energize the Venturi, and then it pulls in air through the port that you can see in the picture, and just by making a couple of adjustments on simple valves, then you can adjust the amount of flow and also the percentage of air to oxygen in the flow. So on the Tuesday evening, I'd kind of thought, I'd been watching the build up to the Australian Grand Prix, if you remember back to that time, and I knew from talking to my colleagues and contacts in Formula One that all the engines had been sealed, but then the race had been called off. So I kind of thought, okay, that means that there's lots of Formula One engineers that, especially on the engine, the power unit side of things, can't really do anything for the time being because the engines have been sealed. And that means that they're going to be twiddling their thumbs a little bit. So I phoned, in the middle of this picture here, you can see him, Ben Hodgkinson, who I first sponsored as a student at UCL many years ago, and then I employed him for his first and second jobs in motorsport before he flew the nest. He was always going to head to Formula One. He ended up at Ilmor, that became Mercedes, and then rose through the ranks. And at this point, he was head of mechanical engineering for the Mercedes high-performance powertrains. So I called him and said, do you reckon you could perhaps just come and have a look, see what we're up to, maybe get involved with a bit of the design? And he just jumped straight in the car and came down to us. Then I thought maybe he could take some time off. So I got in contact with his boss, who's called Andy Cowell. And I sort of said, could Ben perhaps take a sabbatical? So Andy sent a message back via Ben that just said, do not hesitate to call upon the might of what we can do. Which kind of, that to me, is kind of like, that's opening all the doors. Suddenly we're going to get half of a Formula One team to help with our potentially with the manufacturer. Again, this picture here in particular is this is Wednesday lunchtime. So the night before we'd had the meeting, I've called Ben. Ben's just hopped in a car, no questions asked, and come down to central London. And then Dave Brearley, who I mentioned, turned up with his CPAP device that he'd taken out of his museum display cabinet. And if you look carefully on the bench there, the first thing we did, without knowing that it was one of their treasured items, we put the bandsaw through it and started measuring it all up to go through the process of reverse engineering. Because as soon as we saw it, it was delivered in a carrier bag. We were in a restaurant on Torrington Place, just by the engineering department. But as soon as we took it out of the carrier bag, we kind of knew this is our sort of thing. This is what we can definitely do. So it's kind of like, okay, so if we recreated this in huge quantity, then would that be that would be a good thing. You may wonder, why didn't they just approach the original manufacturer, which by that stage it was the rights were owned by Philips. I think it's fair to say I've got quite a good network of contacts, and we found representatives at Philips, and I think best way to describe it is we probably got about one desk away from the person we needed to talk to, who had all of the designs. This was over probably a period of sort of a couple of weeks during the project. But we didn't strike gold, and we ended up having to go through the reverse engineering process to recreate this design, all on our own. So meantime, Ben's come along. We've got some postgrads helping us. I've got other members of we work with quite a few sort of industry collaborators, and I've got them to come and join in. And this is an early team photo. Now, on the far right, this is how. Yes, I've got a good, as Andy Cowell described it, I've got a good sort of black book of contacts that I can flick through. But you never know where the opportunities are going to come from. So the guy on the far right is called Chris Buckingham, and that little screenshot is my wife, who had fallen ill with COVID that morning. She snapped this is on the local news because Chris Buckingham was complaining that he was trying to get in touch with the Cabinet Office. He's a manufacturer of medical equipment and didn't seem to have any interest and couldn't talk to anybody. So I tracked down his details, phoned him up and said, we're trying to do something. Could you just hop in the car and come and take a look at what we're up to? Which he did. Why would he? I don't know. But he came along, and he became the most incredible source of information, because he knew all of the suppliers, he knew all the materials that we were going to be needing, he knew who the manufacturers were of various components. He was absolutely brilliant. He also knew the field so well that he was aware of where threats were coming from. You would not believe that here we are trying to do something to help, but there were quite a few groups out there trying to make ventilators and so on. But unbelievably, they were quite hostile to what we were doing, because we were doing CPAP, which was not ventilators, and CPAP at this stage was not even on the care pathway for treating COVID. So we were doing something against the grain that others were quite hostile towards, and it wasn't on the care pathway. There was no political support for it. So why were we doing it? Well, we were doing it because we believed we were talking to the doctors. And I think this is where it comes down to, I think engineers often, we go charging off thinking we've got a solution without checking that we're answering the right question. And I think the bit that, when I say we've been asked by lots of people, I think what happened was we were answering the right question, and we did that early on, so that we were producing the right sort of solution. So there's Becky, and that's really, she was just such a driving force to motivate people to get all, you'll see in a moment, to get all the way up to number 10, to convince them that what we're doing is also should be part of the solution. Also on this Wednesday, obviously my wife's now, actually she was quite ill with COVID at the beginning. I'm worried, have I caught it? I don't know at that stage. But I sort of left that morning and said, I don't know what time I'll be home, but without realizing it was going to be, it was actually 5 weeks before I actually went back home again. This is how things grew and happened so quickly. So Ben then called in some other of his team, so the design team, and this is in mech space. We literally worked all the way through. We tried to go and get some sleep. So from Wednesday to Friday, we just kept going. When we did go to the hotel, our brains were whizzing round at 1,000,000 miles an hour. It was just, we were so wired, it was impossible to sleep. So we just carried on as best we can. Can you see that it's early hours? There's a few beers on the desk. Corona, everywhere was cleared out of food and drink, but nobody would touch the Corona beer, which is how ridiculous certain things were. By the Thursday, so others have started to hear around the hospital of what we're up to, and so the sort of the political persuasion is now starting. So David Lomas, our vice provost for health within the university, he was an absolute incredible ally, and he didn't know me, he didn't know what we were doing. He knew Becky, and it's a case of, okay, so we're going to trust you, and we're going to see what we can do to change the political decision on how to treat COVID. So we had various VIPs come and see us. This photo always makes me laugh because they come to see how serious we were about everything. You can see my pose there. I just spent the whole meeting with my flies undone, and then it got pointed out just before we took the photo. So you can't be trusted with anything really. But what's happening at this point? The team have gone through the reverse engineering. Next slide, which shows the original device, and so this is by Friday morning. It's actually Thursday, isn't it? Crikey! So this is still on the Thursday, and we got to the point where the Cabinet Office was starting to listen to what we were up to, and we were told we were going to have an audience with somebody in number 10. I think in the end it was Michael Gove who actually took the call, and whether they would actually support what we were doing. So we needed to give them something to explain and convince that we'd made a lot of progress in a very short space of time. And so the design team were very busy putting this, just a simple, one pager that was going to get sent to number 10. Suddenly we were told we were 20 minutes away from the call, and then suddenly, like 2 minutes, we hadn't quite got this slide sorted out. And then I think we were trying to put some logos on it to make, at least give it a good impression. And then suddenly it's kind of like the call, we're on the call now. So Becky literally took a screenshot over Ben's shoulder. I think she swore at him at that point. Anyway, the picture got sent, probably by WhatsApp. I think that was the thing in those days. We got confirmation that they would support what we were doing. So Ben always describes this as being the most stressful 20 minutes of his career, if you bear in mind what he's been doing for a living for quite a number of years. Okay, so we get to Friday. We start, really, this is about what happens if you leave engineers to look after themselves. So the joke within the whole group was that nobody had packed any spare clothes apart from, I think, one person. So sort of we had N+3 pairs of or spare pairs of underwear amongst the whole group. So we hadn't got any fresh clothes, so we sent one of the youngest members of the team out, and all I could find up at King's Cross, St Pancras, was M&S was open, and these are actually pajama tops. So we ended up, this is in the Royal National Hotel I think this is the Friday morning of breakfast. There's a few sort of straggling tourists left over. We just looked like we're sat there at breakfast in our pink t-shirts, and honestly I think people just thought we were a stag do that had gone horribly wrong, was just like badly timed. But what the nice thing about this, if you look at the logo on the t-shirt, it's called Ventura, and that's where the name from the device came from. So the UCell Ventura was born in that moment from that photograph. So, as was mentioned in the introduction, our aim, we set a target. Let's get back into the hospital with our first prototype within 100 hours, and we decided that was going to be possible. So, as you saw, originally bandsaw, measuring, cutting things up. We'd also then got into Mercedes, and obviously they've got all their sophisticated kit, so you can see a nice image section through the device on the left-hand side, and then you can see the original design on the left, and then on the right is the first prototypes that we actually manufactured. Again, although we had our friend Chris Buckingham who was helping with all of the materials, it was also quite nice that we had help with being able to sort of analyze the materials and see what we'd got. One of the little touches that I loved was that there were lots of O-rings in the device, and I just love that the attention to detail that a Formula One team goes to. So even off-the-shelf components like O-rings, they put them on a drawing, and they all go through inspection 100%, because I think we've probably all seen, if we watch any of the Formula One on the telly, that at some stage there's always a manufacturer complaining there's a 5p component to actually stop the car. So this is the level that they go to make sure that that as far as possible doesn't happen. So to give you an idea of the scope and the size of the team, obviously we didn't have everybody involved, but we had a lot of the manufacturing. So Mercedes have got, for their power units, they have a machine shop that's pretty much the size of a football pitch. So the week before, they've been making pistons for Lewis Hamilton and Valtteri Bottas and their customer teams and so on. This week they start manufacturing the bodies for the Ventura device. You'll see in a moment as well that although the Ventura gets all of the headlines, a lot of work is going to go into the patient circuit and all of the periphery components that actually go with the breathing device. So we ended up, the majority of our work was consumed. I mean, it's not a boast, I don't think, when you're working with the Formula One team, but to actually just recreate an existing device wasn't really that difficult. It was difficult to do 10,000 in 4 weeks for sure, and that's where Andy Cowell and his team were actually amazing in being able to ramp up production. So they were producing over 1,000 a day towards the end of that period. But we spent an awful lot of time doing flow testing and analysis. You'll notice that this is Pierre Godolph, who's holding the mask onto the mannequin, who by the way was nicknamed Ace Ventura. But you can see there's a filter, little yellow filter on the outlet of the circuit, and under normal times a CPAP wouldn't have a filter, but because of COVID and the risk of contamination, it has a filter. So what, you may say, but that puts a back pressure into the system, and we soon learnt that the back pressures in the system had a huge influence, A, on the comfort for the patient, and B, on how much oxygen that the system consumes. So we get to Sunday, we're getting towards our 100-hour deadline, and sure enough, we made it. So we've got Andy on the left, Becky, Ben Hodgkinson, Dave Brearley, who I mentioned, who's come out of intensive care in his scrubs, and me. I have a big thing about first impressions. I think it's always so important. You never get a second chance to make a first impression. And I felt that us as engineers, with engineers everywhere trying to, make ventilators and contribute, we're going to go into someone else's environment. I felt it was really important to make a good first impression. So that's why I insisted that we had flight cases almost to the point where it got a little bit, agitated between me and Andy. I didn't want them just turning up in a cardboard box. I wanted them to have, F1 style flight cases, which just sets the scene when you walk into someone else's environment, that we've got some idea of what we're doing. So we met in the quad and we wandered across to the hospital. We sat in on a meeting while we were waiting to go and start doing some testing of what we'd done. You see the look on everybody's face. That was listening to the contents of that meeting was absolutely horrendous, and the decisions that were being made. These are things that came out in the press probably 12 months later, and then got flatly denied by everybody who was involved. But no, I was privy to what was being discussed, and that's one of the things I've learned. I've never been in a situation where I can see either side of the divide. I can see sort of the inputs and then the outputs. I could never understand why politicians weren't being held to account by journalists when they appeared on Sky News and things, because there was you could see what was happening actually within the hospitals and so on. So that's definitely left quite an impression on me. So the first CPAP device, here we go. We're ready to start doing some testing. Ben described it as it was going to be the mic drop moment, that we'd flow tested the device. We knew it matched exactly what we'd done before, and we were expecting, a sort of a pat on the back, and okay, let's just go and make thousands of them. but it didn't work. So we knew that the device worked, but something had changed. So you can see there's a whatever make it is, there's a CPAP in the background. So as engineers, the first thing we did was, well, let's back-to-back it against one of the existing devices. And we soon homed in on the fact that it was all to do with the back pressure. So they put it together how they remembered in the days when they used to use the CPAP. And what this particular pipe, it packages amazingly because it concertinas down into nothing. But as a flow device, it's absolutely terrible because it's got such poor flow characteristics. So we made a very crude manometer out of a piece of medical tube, 10 centimeters of water. That's quite easy to, physically to measure that. And we could see that we were it's a far higher back pressure than just the little relief valve that we got. So we put a T-piece on. We doubled the outlet flow area by we got 2 filters. The back pressure dropped, and then we realised that we were onto something, and that's where we did an awful lot of work, as I said, to find smooth bore hose. Interestingly, the rest of Europe, as standard practice, uses smooth bore hose, but in the NHS we use this corrugated pipe. I kind of since describe it as we have a sort of a £20,000 machine that then compensates for sort of a few pounds worth of plastic and the poor flow characteristics. So I think this is if we just handed over the devices and left them to it, then it would have been a very different story, because they'd probably come back and said, "Oh, it doesn't work. We're not very happy. Thanks for trying, but away you go." But because we were there, we were able to problem solve on our feet, regain their confidence, explain what was going on, and then find a solution for them. So that was 96 hours we were there. Then we get into week 2, and this was really, I'll just flick through this little section. So we were back in the hospital, and it then became about the actual oxygen supply, because it turns out that the whole of the UCLH hospital is supplied by 2 22 diameter pipes for their oxygen supply. No one had ever thought there was going to be a pandemic, so we got involved in measuring pressure drops into different wards. What happens if you have 8 beds in a ward all flowing high flow oxygen? Again, quite a few worried heads and so on. So we worked out that there wasn't going to be a serious pressure drop in the system, even at the sort of the extremes, because also they were turning ordinary wards into intensive care. So that's what we spent the most of the second week doing, and then advising what happens and how they should treat other hospitals that don't necessarily have the same level of supply as somewhere like UCLH. That's the team. So yeah, we also learnt through analysis that we can improve the characteristics of the original WhisperFlow device. So a nice bit of F1 sort of wizardry. They're very good, obviously, at sort of intake flow into an engine. And so with a bit of careful porting, we managed to improve the efficiency of this device quite significantly. It's worth noting that it's flowing oxygen the whole time. So, and it really does, it flow. If you're breathing, you probably need 5 litres a minute when you're sort of normal breathing, probably a bit more if you're distressed and you're suffering from COVID. But a lot of these devices, this particular one will easily flow up to sort of 40-50 litres per minute to deliver the 5 that the patient needs. And even the more sophisticated ones, the screens tell you that they're flowing a lot lower. But if we put a meter into the line, again, they're flowing horrendous amounts of oxygen. The worst ones are up to like 120 litres a minute. And then you start worrying about how oxygen rich the environment is around the patients. That's something else we looked at the following winter to help look at those sorts of levels. Just as an aside, we got thrown out of our hotel, but everywhere closed. The upside was that we all ended up in our own apartments scattered around. This is my view from my apartment for the next until about mid-July. I was living in London and working on the project. And then my daily routine was to run around. I'd do a sort of a 5K run. It's my COVID test before testing was a thing. Make sure that everything was still in working order. This is Camden High Street. I just took this picture because, you know, this was a Saturday morning. It would just normally be packed. It took your breath away. It was like the sort of zombie apocalypse. It was one of those sorts of things. So we get into week 3, and this is where we're going to start the mass manufacture. So I've mentioned that we've sorted out, it's not just the device. We've started looking at the consumables, and we've managed to build up a relationship with the supplier of those sorts of things. And then I sort of started asking around my contacts. Yes, we've got Mercedes to do the manufacture, but it's more than just, you know, the bits that we need for the CPAP. So it's so this is the GTMA, Gear and Toolmakers Association, and I spoke to Alan Arthur, and I think this is perhaps one bit that he's not heard about before, but we did a press release to all the members of their association as a call out to help with what we were doing. And it was going to go, I think it went out at 9 o'clock, and I'd forgotten I'd put one of my industry contacts who was working with us, a gentleman called Pete Weston. I'd put his mobile number on this release because we needed someone if, you know, people were going to ring up and offer to help. And it literally, the clock came around to 9 o'clock, and then I thought, I've not told Pete about the press release. And I was opening my mouth to say, Pete, by the way, and then his mobile phone started ringing, and it literally didn't stop ringing for about 48 hours. So the GTMA, you know, we got such support from them for all of the ancillary bits and pieces that we needed to do. And then, you know, 2 days later, I explained to Pete that I put his name into a sort of a small press release without clearing it with him first. And we're still laughing about that one because you just wouldn't believe his phone did not, you know, it just did not stop for the best part of 3 days, really, at least. Again, so we started the small scale assembly. We started shipping some of these out to the hospital. That some of them are starting to appear in intensive care. Obviously, we get to the MHRA approval within 10 days. So this is sort of the timescale that we're talking about. So, and we ordered the packing boxes that turned up at our workshop in King's Cross. If you see 10,000 boxes turn up and you've not even got room for the packing boxes, you start to realise that you've created quite a problem for what we're doing. You can see there's a meter on the desk there, which has got 20.9 reading the oxygen concentration. That's one of the other things. There were no oxygen sensors. At one point, I stopped the whole team. We literally bought every oxygen sensor in the country. We ended up with about 450. And that meant that we were, you know, thousands short. So I'll come on to it towards the end, but that's one of the other products that we designed and manufactured was an oxygen analyzer to go with the CPAP unit. Again, we start putting these kits together, and how on earth are we going to make 10,000 and get them out into the NHS? So do you remember the Nightingale hospitals? So I'd seen on the news that the army had been involved with the logistics, and I managed to track down, I think his name was Major General Timothy Cross, and spoke to him and said, could you help with the logistics of getting our kit out into the NHS? We'd already learned that sort of the NHS supply chain and so on was very fraught, and it was going to be too slow. So the advice was we should go and do our own thing. He said the bureaucracy will absolutely flatten what you're trying to do. So again, got into my book of contacts, and I got put in touch with GTEM. You can see that they soon became known as JATEM because they were just the most brilliant people. So Nick Thomas stood by one of the pillars towards the back, and this is probably the one hunch of the whole thing that I had, because we'd spoken to people like, you know, Amazon, DHL, Google, so on and so forth, about how they could help us. Nick just seemed like a really genuine person who was really keen to help. He didn't. His first question was, what's your budget? He was just like, how can we help? And we teamed up with them, and they were just miracle workers. They were absolutely amazing. So this is just a few shots. I've since been around their place. What their day job is automotive, and if you take the panels off a car, that whole chassis subframe underneath of beautifully sort of pressed steel or aluminium, welded or bonded, then that's what they can do. They do all of that. And the reason we went with them was because they have a 6-hour horizon for supplying onto production lines, so they are all about just-in-time logistics. So we worked with them, and we set up a supply chain so that we could get our whole CPAP kits, which was the device, the breathing circuit, the oxygen analyzer, the masks, you name it. Just open the box and away you go. We could supply anywhere within the UK and the devolved nations within 24 hours, thanks to their help, which beats anything that the NHS could do. We set up a clean room facility because when we got all the components for putting our circuit together, so the pipes, the filters, there's 2 types of valves. One's high pressure, one's low pressure. The high pressure one is kind of like if it all goes horribly wrong, it's a proper pop-off valve. And we went to the hospital to see how they would put them together. Now, if you watch them, it was just scary to see when they're just sitting there having a cup of tea, and there's no pressure on them as such. They'd throw the instructions over the shoulder, and they just pick the bits up and just start trying to fit them together. So we kind of thought someone's going to suffer for seriously if they get this wrong. When they're in PPE, they've been working all hours, it's stressful. Then we don't want to put them in a situation where they're trying to assemble under that sort of pressure. So we set up a clean room to do all of it pre-assembled, and then you put into nice big boxes, and then all you had to do was open the box, plug the patient circuit into the CPAP. And again, I think this is sort of the engineering approach to go and walk in the shoes of the people that are on the front line, understand what their problems are, and then provide the solutions from that. That's only a few hundred boxes. Bear in mind that we've made 10,000 of these kits. About 6,000 of them have been actually sent out and used, and there are obviously the remainder are in store for sort of future response. So, getting towards the end, the overall impact. So we made 10,000 devices in 4 weeks. We've supplied to 130 NHS hospitals out of about sort of 200 plus. Apart from the CPAP, we got 6 special authorizations through the MHRA, and as I say, perhaps the analyzer is one of my favorite bits. So this is the oxygen analyzer. I just had a thought that could an exhaust pipe lambda sensor be repurposed as a medical grade oxygen analyzer? So I previously, when I was working in motorsport, our sister company did all of the electronics for engine control and chassis and so on. So I got in touch with my old boss and said, could we turn a lambda sensor, which has a very narrow band of operation, could we turn it into a sort of a ambient air to 100% oxygen analyzer? And in simple terms, that's what we did. So we made in total 10,000 analyzers to go with it. So just a little slide to show you the timeline. So 100 hours prototypes, 10 days for the MHRA approval, and then it was 10,000 devices in 4 weeks. Let me just skip through a few now. So as I sort of mentioned, where it got used in the NHS, we didn't stop there. So we released all the designs as an open license. So you could apply for a license, and we'd do basic checks, and we drew up a contract so that we made sure that it was all not for profit. Anyone who signed up, and we ended up with about, I think it was about 35 countries have actually put them through approval. We can account definitely for about 25,000 devices. We think there are probably about 40,000 that are out there somewhere. We also made donations to sort of low middle income countries. That's the thing that's really the lasting thing that I've come away from this, is how lucky we are with our healthcare provision. You really don't have to go very far before you don't have any oxygen, you don't have any, there's just no equipment, there's no facilities. It's really that part of the project, when you start realizing just how poor things are, and also the big organizations are they're not in a position to be able to help. So that we found really quite distressing when we came across that, which is why we did the open source. Just a few shots of some of the teams and some of the devices that have been made. Every time we received these, it was a real sort of boost to the team's spirits to see what was happening. And this has been going all around the world. So the list of countries is quite amazing. And then in more recent times, we helped with donations, in particular to India. There was quite a large donation went out there. So this has then been sort of loaded onto freight, and we've personally got involved with a particular hospital in Uganda, in Horona, where we've helped to get an oxygen concentrator out there. So this is working with IMET 2000, which is a charity that we've built a very close relationship with. As I mentioned, the 6 devices in total. So 2 CPAPs, 2 oxygen analyzers, a little flow monitor for the CPAP device, and a breathing hood. If you're on a mask for 5, 6, 7 days, it does become horrendously uncomfortable. You start losing the skin around your nose and so on. A hood is an alternative to help treat patients, and that's my colleague Tom Peach. We spent many hours in the hospital as volunteers, as healthy volunteers. And then just a final slide of Dave Brearley, happy Dave Brearley. He was, again, Dave and Mervyn there was a couple of times where they'd work a night shift, they'd work with us during the day, and then they would go back in for another night shift. It's, their stamina was quite something. Quick little snapshot of the team. So that's us on the cobbled stones outside mech space, and then it's really a core of UCL. I think that's where it worked. We had this sort of golden triangle. We had the engineering, we had the healthcare, and we had the hospital as well. So that was really the key to our success. So that pretty much draws it to a close. I'm really happy to take any questions, and it's hopefully that gives you a bit of an idea of what it was like being involved with something like that.
Thank you very much, Tim. That was really gripping. I can see that the audience were just stunned into wondering what on earth to ask, and I can see questions are popping in as we reach the end there. An amazing journey, and can you imagine that happening again? Would you want it to happen again?
Well, I've got I've not put it up, but me and Becky have actually we handed everything back to the NHS in September 2021, which really isn't that long ago. But we couldn't just walk away. There's still countries all around the world still, struggling with COVID. So we've actually set up a new initiative to carry on. I think it's only a matter of time before we're going to be facing something similar. But I think that the disparity between the facilities we have, that's what we couldn't leave behind. It's quite simple to help. The problem is that you've got all these big manufacturers. There's no money in selling to low and middle income countries, so they're just not interested. Whereas if you can, we're great believers. There's always a way to make the devices so that they can be run off a cylinder of oxygen. Because at the moment you can't run a CPAP device or a ventilator off a cylinder of oxygen because you'll only have a couple of hours of use.
Right. Okay.
Could I imagine it happening again? I'll tell you what, if someone had said that we were going to make 10,000 devices in 4 weeks at the beginning, there's no way. It happened sort of, organically. And suddenly it was 4 weeks and we'd made 10,000 devices. It's funny how we just picked away at it and solved the problems. And yeah, it's, and again, we sort of appear in the headlines, but there are thousands of people that we pulled together as this huge team to make this happen. It wasn't beyond Mercedes. We've got. I've not really mentioned it, so they were on the final slide. Intersurgical and people like that. Just so many people we managed to pull together.
And your Little Black Book seems to have been one of the key components to all of this. But you're very fortunate there at UCL that you've got the hospital and you've got your department doing the mechanical engineering. Do you think it could have happened without the serendipity of those things being in very close proximity?
So again, we've been asked a lot, how did we make that happen? And I think it's that close collaboration with industry, and it's beyond just kind of like research groups, because let's face it, there are universities all around the world that could have, would have, should have, perhaps done something. But I think we were just unique in that respect, that we had those ready built relationships with the people and the trust. We had to do a presentation for the Cabinet Office to explain how we'd done it. And it was only then that Andy Cowell realised that we'd never signed an NDA or anything between us and UCL, because we already had that relationship, and we started immediately. So I think that's the thing to learn. The regulation has gone back to its usual pace.
Right.
There are lots more people now involved in that part of the chain. They're all, there's lots of people making money out of it, dare I say, whereas they weren't there when it really mattered. So do they need to be there? Yeah. There are lots of consultants and specialists and that sort of thing. So
and I think we're starting to see now in the sort of, although the pandemic isn't over, we're starting to see something of a wash up, that people are going back over what happened and using the fabulous spotlight of hindsight to say things should have been somehow differently to the way they were. Do you have any feelings of hindsight, if we'd done it this way, or if we'd done something in a different sequence, it may have made a difference? I mean, obviously, in some ways it's a difficult question because you have been successful. So the retrospective hindsight can only be better, I think.
The way I would answer that is we were seeing a lot of those things in real time, and it certainly wasn't hindsight. And I think if we weren't recording, I'd probably I'd share a different opinion. Is it fair to say that? Because a lot of what we experienced and I mentioned that we had people trying to stop what we were doing.
Yeah.
What on earth is all, what's that about?
Yeah.
It's just, yeah. So,
yeah.
and the way, it could be done. It could be done an awful lot better. There were some key people. There's a guy called Chris Sterling who was our cabinet office representative, who we spoke to every 2 days, and he became responsible for medical devices. He was a superstar, but when you learn afterwards that he'd obviously worked in those sort of civil service roles previously, but he was asked to just look at the oxygen supply problem for a couple of days, and then ended up brilliantly running the whole medical devices. And you just kind of think that's just luck that he was there.
Yeah,
it could have been so different. He spent 18 hours a day in front of his webcam, meeting after meeting after meeting, coordinating the whole thing. And we'd literally, our slot was at 5:30 in the evening every 2 days, and he'd be there, and his wife would appear and slide a plate of food in front of him, because that was his feeding time, and he would shovel the food in without even looking at what it was. And that was a routine every time we met him. But he was fantastic. So there's some incredible people. Yeah, Neil Maguire at the MHRA. He was some brilliant individuals, really, really good. But it could and should be a lot different.
I wonder if it were in some ways a lesser severity of pandemic, whether people would have cast aside their natural unwillingness to accept change quite so readily. I don't know how you felt in the thick of it, but it seemed like things were there wasn't an obvious end in sight, an obvious end game for people, and it's almost like the feeling of a last point of desperation. Well, we'll try anything, and I wonder if that helped to sweep away people's natural reluctance to accept something that they don't understand or haven't done before.
Yeah, I guess so. It's looking back on it, how we got involved is I wonder about a lot of some of the other groups, what their motives were for becoming involved. I think that would be quite interesting to look at, because our budget was agreed on a conversation. It was one of those ones, right? Okay, there's X amount of hospitals. Can you do it for we were going to do the CPAP and the analyzer for £2,000, right? We'll write you an order for 20 million, and out of that we also did the whole, all of the breathing circuits, the hoods, the pressure monitor. We set up, we ran all of the logistics, and we gave them £4 million back. So,
wow, that was very generous.
So, yeah, I mean, it's an open book exercise, and that's the other thing as well. We did it entirely as an open book exercise. So, So, whereas there were others around that. Well, we pick up on some of it, I think, in the press these days, don't we? So
yes, in some ways, perhaps analogous position is AstraZeneca with the virus, taking a similar approach and to not wanting to profit out of it, and yet they received a lot of brickbats. Who knows, possibly with some influence from those who've made a great deal of money out of it. There's always doing good, and then there's money as well.
Yeah.
Paul McMaster on the chat says you should write a book about this, and I can see if you did, and then you put all the juicy bits serialized in the Sunday newspapers, you'd be very popular.
Yeah, yeah. I think again, we've got we know enough to yeah. But then again, a lot of it doesn't seem to stick, does it? No.
Yeah. You can't quite use the Sunday newspapers as chip wrappers on Monday, but yeah.
No, that's it. Certainly along the way, we've had those investigative journalists have spoken to us because they looked at all of the groups that were doing things just to see where the money had all gone, and we were kind of like, yeah, come and have a look, absolutely fine. But then in doing that, they then got talking to us about what some of the others were doing, and we were aware of certain things. So maybe one day that will come out in a book. There are discussions about writing the book for sure. It would be fun to do that.
And are you selling the T-shirts? Because I think merchandising, that's a great opportunity for you as well.
Yeah, that's it. We have got a few of the T. I mean, isn't that ridiculous though? How that came about? Yeah, we were sitting in the room. Yeah, we were sitting there with the Corona beers and everything, and yeah, sort of two or three of us at the same time were kind of like, hang on a second, this is. UCL were resistant to the name, by the way, and we were insistent that no, I'm sorry, it's this is what it's going to be, because it's just the whole spirit of the way it was building. I had a lovely one of our allies described it as, it's all very, very well for all of these people who are pontificating in self-isolation to be trying to tell you what to do. So we stuck to our guns, and UCL Ventura became the name.
I was wondering, actually, I'm just going to bring in my colleague Paul. He's been monitoring the questions that the audience have put forward. So Paul, jump in the conversation as well in a moment. But I was wondering, you were working around the real heat of where COVID was happening in the hospital and so on. Was that worrying? Did you said your wife had the illness, but was that something you were always conscious about, and what did you do to combat that, both mentally and physically?
Sure, I don't think it's quite laughable now. You look back at those photos and we're all stood next to each other, because at the very beginning we were having the place cleaned twice a day, because we thought it was all about touch surfaces, and we weren't all using the same toilet and things like that. We were and yet we were we weren't. It was all elbows and all that sort of thing. But that picture where Ben is stood there with the case open, and then he's sitting in the middle of us in that meeting in the hospital. Turned out, he goes to Dave Brearley, I've got a bit of a headache. Has anyone got any tablets? And it turned out he was coming down with COVID at that point. Wow. But none of us. So we were very much expecting that we were all going to sort of drop like flies, and it would be last person standing. But we managed. I think we got through that point where we were then all living in this little bubble. So we were all living in our apartments and then coming into the engineering centre. But then, in particular, it was me and Becky, and then you saw Tom Peach. We were quite regularly going to the hospital, and we didn't actually go into intensive care. Becky did a couple of times, but we were that close to it, and it was. I'm telling you, it's flipping scary. The rats were dying in the street because there's nobody around. There's no food. There's nothing. Everywhere's closed. It was scary.
Did you have to have special dispensation to be not working from home, as it were? And was that the time when the restrictions were in?
So we became honorary members of the NHS, and we had a letter. It's still around somewhere. It's all a bit crumpled and so on. But I had a letter from the Cabinet Office that I kept in my, kept with me at all times. So like when you saw me doing my run around Regent's Park and back through Camden, I'd have that letter with me in case I got challenged by anybody for being out. So, yeah.
Wow. So, Paul, do you want to come in with some questions from the audience?
Yeah, it was a brilliant presentation there, Tim. I Oh yeah, I was sat on the edge of my seat for most of it just to see what's happening week by week. But yeah, brilliantly understood. It's great to see some British engineering, some manufacturing in play that's done so good and so quickly too. So it's something quite proud, even though I wasn't involved in it. Quite proud to have seen it and witnessed you talking about it. Interesting. We've got quite a few questions though, so I'm going to pick through them as best I can and combine many of them together into one. There's been quite a few around Philips, and particularly the original design and their support or probably lack of. Was there any difficulties that you had with dealing with Philips? You said you came really close to the design. Was there any fears that they might pull the plug and get the legal people onto you about intellectual property and so on? Notably, it must have been frustrating that they weren't really there to say, we'll support you, we'll give you everything from the get-go. What happened there? How did that make you feel?
Yeah, I think that captures almost like everything to do with the project, because as I say, we were so close, and I've since spoken to the person we needed to speak to, and they would have quite happily given us all of the drawings for sure, because that product is no longer really part of their range. And it's also a good example of, I was saying about these big manufacturers, that it's not going to make them money anymore. So they've moved on. A lot of it is very much about the domestic market, and some of those suppliers now, it's kind of like a domestic CPAP, or people who've got health problems, that if they can still hop on an aeroplane and have a small portable device, then that's kind of like where the money is for those manufacturers. And as it turned out, we had our team desperately trying to search the patents, and we were going along the lines of, it's better to ask for forgiveness than permission, because we kind of thought, come on, it's 15 years out of general use, and the patent had lapsed 6 months previously. So we found that out just as we were scaling up the manufacture. So we knew we were home and dry. But it was I don't want to cast Philips as being anything other than very supportive, and it was lovely to then talk to them, and wow, you've gone and recreated this device. So I mean, it's pretty much identical. We are going to catch up at some stage and get their drawings out and put them side by side with ours. There are nice little things. There's an on-off knob, and we kind of looked at it, and there has a scroll on it, and we kind of thought, it's quicker to just make, just machine the helix without the funny little flat that they've got on it. So you make your first prototype, you put the pressure behind it, and it just pops the knob open, doesn't it? So it's like, okay, that's why it's got that flat on it.
It's quite good to see that you did your prototype, the very first one, even if it's 3D, and then you made some iterations. You had the MHRA as the first one and the second one, and so on. I mean, people have asked these questions about where it might be used or developed for other things. Have you thought, it might be worth the university or others to keep the project going, to keep it, improve it in some way, bring the oxygen meters into one complete product and so on? Has anything been thought about on those side of things? Someone here mentions a question about sleep apnea, for example. Yeah,
exactly. Is it okay if I just quickly reshare my screen in that case?
Yes, of course.
Yeah. Okay. Let me just. I think if I go back to that one, is that back into the slideshow? Yeah. Yep. Okay. So just to explain that one, then there we go. So we've carried on with a not-for-profit, because it's you have to come at it from a completely different angle. So if you're going to create a device for low and middle income countries, to give you the context, you've got people who are doing things like oxygen generators. Now, I don't think I'm giving anything away if I tell you that when we spoke to the WHO, and they actually stipulate that oxygen concentrators or generators have to be able to supply 10 litres per minute. That is the WHO thing, which is good for nothing. And when you scratch beneath the surface, and it's lifted from documentation that came out a few years ago, word for word, it's just almost like a lazy cut and paste. So we sort of challenged them about this, and then they didn't talk to us after that. And then you discover that 10 litre per minute has come from the manufacturers who supply domestic devices that flow 10 litres per minute. So this is where you've got this horrible conflict of where follow the money. Where's the money? Where's the profit? So they're happy to sell 10 litre per minute oxygen generators because they're happy to sell those for good profit to smokers and so on and so forth. That's where their market is. And then you've got the actual CPAP devices that are high flow, and you find that you've got these hospitals being told, oh yeah, no, the oxygen generator, the concentrator, yeah, that will supply these devices, no problem. And you've got the device manufacturers clearly saying, oh no, these will run with the generator, absolutely no problem. So then they buy them both and they put them together. Doesn't work. So this is what we're doing. We're engineering so that we as we call it, a zero loss CPAP. You might remember I mentioned 5 litres per minute is what you need, and we've got devices that are delivering 50, 60 plus litres per minute. It's kind of like, why can't you have a device that delivers 5 litres per minute? You just breathe what you need. You don't put your scuba gear on and you're bubbling away the whole time, wasting 50 litres a minute of okay, it's only compressed air, but it's ridiculous. So that's what we're doing, and our aim is to be able to ideally we'd love to give these away to sort of low resource settings, because then they can run them with cylinders. It's like with India. Do you remember in the news when everyone was queuing up to get their oxygen cylinders filled? Yeah. For us, that's heartbreaking, because it's going to last 6 hours if you're lucky, and people are spending 2 months' wages. And it's just, and we just sort of we sit and watch that happening. The medical world knows that it's not going to work, and nothing seems to happen about it. So that's one side of it. And then we're also looking at vital signs monitoring, because again, okay, we did oxygen analyzers, but every single piece of kit has embedded electronics, and it has a screen, and it has to be plugged into a socket. If you can get rid of all of that, then the energy usage goes right down. And there are things starting to appear, but then everyone's doing it because they want to harvest the data and send it to a call center so that you can monitor at home and all of this sort of thing. So their reasons for doing it are different to what's really needed in those sorts of settings. So that's just kind of what where we're headed. So this is actually outside of UCL, but fully supported by UCL. It's difficult. UCL can't be a medical manufacturer, which is one of the. We've actually, nice little slide. Mercedes HPP are about to get their approval as a medical manufacturer. That's one of our proud little moments. So yeah, they will be a classified medical manufacturer as well as 8 times world champions.
Wow.
No, they clearly see the commercial benefit to having those skills and retaining them and making use of them. So it's good to see that your legacy is going on, and it's good to see that things are going to be continued to improve. There's always that the Brits are always quite good at doing something very, very well, and then just go, oh, what's the next thing? And it all falls by the wayside, never gets manufactured. And then 20 years later, you talk to older engineers and they go, oh yeah, well, we did that 30 years ago. And you think, well, why aren't we doing it now? So it's great to see that someone has the foresight to go, we must continue this. We can't lose that. You mentioned very quickly there about the oxygen flows, 15 minutes per minute, 10 minutes per minute. So Martin has asked a question, he says, you mentioned also in the presentation that there's a lot of wasted oxygen in the usage of it. So, was anything done when you were looking at innovating those designs, and certainly when you're improving upon them, to look at ways that could be reduced and even recycling any lost oxygen? Yeah,
sure. So if you get to the real high-tech ventilators, then they are closed systems. But then what happens then is you can scrub the CO2 with soda lime. But then that just moves the resource setting. It just moves it down the chain. Suddenly you're saving oxygen, but then you've got a soda lime issue because that it uses a lot. So it's if you can reduce the oxygen use at source, that would be the real trick. So one of the things we discovered, there are lots of different masks, and there's a really nice a twin port mask, and it has an inlet and a separate outlet, and they have those nice little flutter valves in there, and that massively reduces the consumption. So again, one of the things that we did was when we came through, I can't remember, the second or the third peak in the second winter. We worked with Chris Sterling, who I mentioned, and the NHS, and they had a hit squad that were going to the hospitals that were really struggling for oxygen supply, and get them to transfer over to using these twin port masks, and that would reduce consumption by about 40%, and go from being critical to being manageable. So again, he said to us when he thought that was probably our biggest contribution to the whole thing, was to tell them, we were saying this for months, go and use this mask, go and use this. And then when it got really critical, they went, oh, what, this? Okay, we'll go and use this one then. So how do you get that message across? I don't know. Yeah.
No, it's always a very, very tricky one. It's in innovation as well. It's always some scary moments. I've got a question here for myself. Really, is this was a very fast design with a small team, with probably very, very, very high risk, considering life was at stake. It was and you had a highly skilled team. No one can question that, but it was only a small team doing the work. Was there any point that and be honest, was there any point that you thought this could kill someone if we'd not done it right? We're in a very tight timescale, particularly when you were doing your first trials. How did you deal with that emotionally? Because they must have been some very, very stressful times and worrying times for the entire team.
Yeah, and I think it's Andy Cowell. He briefed his team that then came back to us, that imagine that it is your mum, your grandmother, your grandfather who is on this device. So yeah, we were very, very aware of it. Like I mentioned about the two valves. I mean, I saw that and I thought, we're going to kill somebody. This is going to happen. When we met Neil Maguire for the first time on the MHRA, it took a lot of pestering to get the MHRA to listen, because it's ventilators. And then there's this lot going, we're doing CPAPs, and it's like, for God's sake, who is this UCL lot we keep hearing about? So eventually we got enough pressure for them to listen. First thing that Neil Maguire does when he comes on, because we kind of think, oh, we've cracked it here, the MHRA are going to talk to us, and he goes, oh, I remember the whisper flow. Yeah, the last time I was involved with that was in the coroner's court when somebody had died, and we were like, oh, God, yeah, this is. But that really, I think that really helped to focus us as well. So there were things that sort of came together. So that's why we went and pre-assembled, because that would have gone wrong for sure. And we made sure on that line, how do you make sure that you don't put the wrong line on the wrong part of the circuit? Motorsport, we always, there's always a come on, it's not rocket science. But when it got stressful, it was always like, come on, we're not saving lives. And then suddenly we're looking at each other going, oh, okay, so what's our mindset now? And it was a challenge, definitely. It's when it all ended, I did find it quite difficult to sort of, living on adrenaline for 12 months and then trying to wind that down. It certainly has been quite a challenge as well. Yeah.
So picking up on that, you've effectively made your production of 10,000 as a big batch, and you clearly had very skilled people making it. It was basically Mercedes that made all the units. Is that right?
Yeah. Yeah.
So were you concerned? And this comes to a question from Matthew Radford. Were you concerned that when you were handing your design to people in other countries far away that you've probably never met, would they produce the product to the same level of quality in the areas that mattered? And
that's it. So we've given an awful lot of support to answer lots of the technical questions. We designed it in such a way that it would be kind of like, 3-axis machining would do most things. But then you realise that a lot of them haven't actually, their technology, they haven't got CNC lathes and so on for just turning the high precision sort of needle valves and bits and pieces like that. So what we did, we sort of did a hybrid with them, and I think this is something we'll take forward in the future. So they had either the difficult to source items or the difficult to manufacture, and we helped them with the supply of those components. Silly things like in motorsport, you can get any O-ring you want, but elsewhere in the world, that's not going to happen. You really do have to go for the very standard components. So we just helped with supplying O-rings, the fiddly ones, or some of the turned components. And I think this is one thing that, again, with what we're trying to do now is you can't, what we do in the future, you can't just make them and then put them in a box and send them to Paraguay or Peru or wherever. They've got to be able to service them, because there's so much kit out there where there's a component, that our hospital, Horona in Uganda, the bulb's gone on their dental chair. They can't, so we're helping them find a spare bulb, because there's no way that they can, it's kind of that sort of level of basics that they haven't got. And we've learned that if you can get them to local manufacture or at least local assemble, they've then got the pride that comes with that. And they've made these devices and they've got them through their medical regulation. They look to us and the MHRA, and if it's good enough for the MHRA, then it's going to be good enough for them. So that's one of the other real sort of takeaways from it.
I'll wrap this up with one sort of question and stroke comment that kind of combines many of the remaining questions we've got left. Clearly, our audience are hungry for more information and they want to know more, but there's been a lot of comments around how emotionally proud you must be, certainly of the team. There's a question about how you kept the team safe, particularly in those early days when everyone was really quite in fear. People, great comments about the Ventura name, why you called the option and going back to the question about writing a book, there's clearly, to do something this quick in 4 weeks in the UK that's not really recognised for manufacturing and for engineering, it's worldwide seen as the banking world or something other than it. Certainly it's not for British manufacturing. Even for myself, looking at the startup entrepreneurial sphere, to see how quickly something can come together and make such a big difference and potentially highly commercially viable, people clearly want to see a book. They want to see more, they want to read more. And what about a film? They did The Big Short, they did that, and The Wolf of Wall Street. They were, properly criminals to a degree. This is a large success story. So I think you need to get your black book out again.
Yeah,
I think I could see Steve Coogan playing the Tim Baker role.
Who played Michael Cove?
I'm going to take that back to the team, because we did on our WhatsApp group. We did have the fantasy film actors at times as to who would play who. Mervyn wanted to be George, played by George Clooney. I don't think we ever tied anyone down for me, but Steve Coogan, that is.
Yeah. No, seriously, I think you should get your book out. I think you should pick up, write the story. I think people clearly want to read it, and I think certainly young engineers could see it be inspiring to be part of something that makes such a big difference.
Yeah,
to how the young generations think now. So honestly, I think you should think about it. Yeah.
No, I think we're doing once we find the right person, we're certainly thinking, we want to do it for sure. It is a fascinating story, really, isn't it? It's nice doing things like this, because when you're so focused on it, just doing this, it just makes you stop and realise, wow, it was quite something that happened. It really was.
Mm.
Yeah.
Congratulations. It was a pleasure to have met you and heard your story too.
No problem. Thank you. So,
Thanks very much for bringing in the
yeah.
audience questions, Paul. So we're pretty much running out of time now, and just really to wrap up and say a huge thanks. It's been a fantastic story to hear, and even better to be able to chat about all the different aspects that weren't in the story but will be in the book. And we certainly wish that you can go forward and come up with some other projects of equal weight, but hopefully not in quite such stressful circumstances. And so on behalf of everyone who's watching, and the comments coming through on the chat are really extremely appreciative. So thank you very much again, Tim. We very much appreciate it.